Going to talk about properties. We talked about properties just a little bit in the beginning of the year, but we're going to now revisit them so that we can go into them in more detail. And you're going to notice that we're going to have both numbers and we're also going to have variables in our properties. So your goal for today is I can identify properties being shown in numerical expressions and algebraic expressions. And if you remember, numerical means number, and algebraic means that there's at least one variable, and variable is just a fancy word for letter. Okay? All right, let's get started. So before we dive right into the properties, we're going to do a quick exponents and order of operation review. So with these exponents, it's asking us to write it in expanded form. So we have a base of 4 to the 5th power. So we're going to go 4 times 4 times 4 times 4 times 4. And that'll give us 1, 2, 3, 4, 5. So 4 is being multiplied to itself 5 times. Here we have a base of 6.1 and an exponent of 2. So that's going to be 6.1 times 6.2, times 6.1. And that'll give us 6.1 times itself 2 times. Over here we have a fraction base of 1/8, and you'll notice that it's in parentheses, so we should keep that same habit, and it's to the 3rd power. So I'm going to have 1 over 8 times 1 over 8 times 1 over 8, and that'll give me 1/8 times itself to the 3rd power. And last but not least, we have 9 to the 0 power, and anything to the 0 power is very simply 1. Now, just a quick thing to note, you'll see that I wrote multiplication in 3 different ways throughout this exponents review. I used dots up here. I used an actual times X symbol here, and the reason why I didn't use dots is because I didn't want my dot to be confused with the decimal point. And with fractions, since they're already in parentheses, I just put them all next door to each other. Okay, now let's write these in exponential form. So we have a base of 2, and it's being multiplied times itself 1, 2, 3 times. Over here I have a base of 7, and it's being multiplied times itself 1, 2, 3, 4 times. And over here I have a base of 10.9, and it's being multiplied times itself once. Don't get confused with something to the 1st power and something to the 0 power. Anything to the 1st power just means it's being multiplied times itself once, so it's just that number. But anything to the 0 power is going to be 1. Okay, a little order of operations review. I'm going to write our PEMDAS at the top. Alright, so here I have parentheses first, so 4 plus 5 is 9, and I'm going to rewrite the rest of the problem. I've done my parentheses. I don't have exponents, but I do have multiplication and division. I have division right here, which is 2. Rewrite the rest of the problem. 9 minus 2 is 7. All right, over here I have parentheses, but there's nothing inside the parentheses. I noticed that it's just next door to another number, which would mean multiplication. But I do have exponents. So 4 to the 2nd power is going to be 16, and I'm going to rewrite the rest of the problem. I don't have any more exponents, but I do have multiplication division right here. They're next door to each other. They're touching with parentheses, and that means multiplication. So 2 times 6 is going to be 12. And I'm going to rewrite the rest of the problem. And now I just have addition and subtraction, and I do it in order from left to right. So 16 plus 12 is going to be 28 minus 10, and 28 minus 10 is going to be 18. Last but not least, I have parentheses. 8 minus 3 is 5, so I'm going to rewrite the rest of the problem. And I'm going to change that multiplication sign to a dot. I do have an exponent, which is 25. And I'm going to rewrite the rest of the problem. Okay, I do have multiplication division. I have multiplication right here. 4 times 3 is 12. And when I rewrite the rest of the problem, I get 12 plus 25, and that's going to be 37. All right, let's jump into a quick expression review, and then we're going to head to properties. So this is the word form, okay, and we need to write it in a numerical form, if you will, but it will have variables in it. So the product, that means multiplication, of 15 and n. There are several ways we could write this. We could write 15.n. We could write n, and let me sort of box them off so that you don't get confused. We could write n dot 15, but the best way to write it is 15n. It's the cleanest way. Okay, here we have, and let me switch colors, we have a number less. So for my number, I'm going to use x. Less means minus, and then we have 135. So a number less 135. So that's going to be x minus 135, because it wants me to make this, it wants me to make the number x that itself minus 135. Okay, we have the quotient, which is division of 20 and a number. This time I'll use y. So quotient is 20 divided by y. You could also write it, if you want, as a fraction, 20 over y. Okay. All right, let's go to 2 added to the product of 7 and a number, and this time I'll use k. So this is one of those two-part problems. So first I'm going to do the product of 7 and k, and that's going to be 7k. And it wants me to add 2 to all of that. So I put this guy in parentheses, and I add 2. Now there's a couple other ways that you could write this one. You could write 7.k and put it in parentheses and add the 2. You could also do k.7 and add the 2. And then you could also have these exact ones, but have the 2 on the left-hand side. Because it's addition, it doesn't really matter where it goes, whether it's on the left or the right of the parentheses, because order of operations will tell you you have to solve parentheses first. Okay, now we have y increased by, so that's plus 6, then tripled, so that's times 3. Okay, so let's do the y increased by 6 first. So I'm going to do y plus 6. You could also do 6 plus y. Now, whenever I have something that's in two parts, I know that my first part's going to go in parentheses. So all of this tripled, so times 3. And I could also write this many different ways. All right, let's jump right into properties. So with properties, it's easier sometimes to sort of guess what the definition is, because it's going to help you sort of better see how the property works. Okay, so this is the associative property, and we also call it the grouping property, but I need you to go ahead and refer to it as associative. And here's some examples of associative. 17 plus 2, close parentheses, plus 9 equals 17 plus parentheses 2 plus 9. So something that you might notice there is that the parentheses changed, but did the order of the numbers change? Not quite. Let's check the next one. Open parentheses 2 times 2, close parentheses, times 4 equals 12 times open parentheses 2 times 4, close parentheses. So same thing. The order did not change on either side of the equal sign, but the parentheses moved. Okay? Open parentheses k plus 9, close parentheses, plus j equals k plus open parentheses 9 plus j, close parentheses. Again, the order of the variables in the numbers, k plus 9 plus j, k plus 9 plus j, it didn't change. The only thing that changed is where the parentheses were. Okay? Now, one thing I also noticed is that here I have addition, I have multiplication, and I have addition. So something's telling me this is only with addition and multiplication. So let's look at the definition. So the definition is when you are only adding or multiplying, you can group any of the numbers together, which means that you can move the order around as long as all you're doing is adding something together and all you're doing is multiplying something together. Okay, so you can move them, you can move the parentheses around in any order. You can group them in any order. We could have five different numbers and move the parentheses into different places as long as they're all being added together. The big takeaway from the associative property, though, is that it does not, under any circumstances, work with subtraction and division. And I can show you why. So, if we have 2 plus 2 plus 4 plus 7, okay? So I can add this up in any old order that I want, okay? So 2 plus 2 is 4, plus 4 plus 7 is going to be 11, and that's going to give me 15. And if I put the parentheses in any different order, I'm still going to get 15. But let me show you what happens with subtraction. Same numbers. 2 minus 2 minus 4 minus 7. Well, okay, I'll put some parentheses here and some parentheses here. So 2 minus 2 is 0, minus 4 minus 7. Well, you haven't learned about negative numbers yet, so you can't really do that, okay? So it does not work with subtraction and division. All right, let's look at the next property. So the next property is commutative property. And again, let's look at the examples first. And this one is also called the ordering property. 18 plus 9 equals 9 plus 18. What did they do there? If you're thinking, oh, they just flipped the numbers around, you're right. 15 times 2 equals 2 times 15. Same thing, they flipped the numbers around. A plus C equals C plus A. Oh, they just flipped them around. DE equals ED. Same thing, they flipped them around. Let's look at our operations. Well, addition, multiplication, addition, and we know that when they're next door to each other, it's multiplication. So again, we're only seeing examples of addition and multiplication. So let's check out our definition. You can add, there's our addition, or multiply, there's our multiplication, numbers in any order that you want to. So if you multiply 15 times 2, you're going to get 30. If you flip it around and do 2 times 15, you're still going to get 30. But think about it in terms of multiplication. 15 minus 2 is what? 13. If I did 2 minus 15, again, we haven't gotten into negative numbers yet, but that answer would be negative 13. So we had two different results, two different answers. So it only works with addition and multiplication, and it does not work with subtraction or division. All right, let's look at distributive property. We did talk about distributive property earlier in the year just a little bit, but the good news is we are going to spend the next 2 days only on distributive property, okay? So here's sort of a quick view of it, and I'm sorry I didn't cover up the definition soon enough. So what your original problem is going to look like is something like this. And if your teacher asks you to distribute papers to the class, well, it's quite simple what you're going to do. You're going to pass out the papers to the class. So with distributive property, you look at the number outside of the parentheses, and you're just going to pass it out to everybody inside the parentheses. So I'm going to write it just a little bit bigger here so that I can manipulate it. So my 6 is outside the parentheses, but he's attached to it. He's next door. There's no plus, minus, division sign, okay? So I'm going to pass him out to the n, and I'm going to pass him out to the 4. And what happens is I have 6 times n, which is 6n, and we're going to talk more about that on Thursday. Then I bring down my sign that was originally in the middle. Okay, so I bring it down, and then I have 6 times 4, and that's 24. And so I have distributed, I have passed out the number on the outside, which gives me 6n plus 24. And again, when we see the letters being multiplied to the numbers, we're going to talk about that more on Thursday. So the definition is multiply the term on the outside of the parentheses with each term on the inside of the parentheses. Okay, now we have the additive identity property. Additive identity property is very basic. Look at your keyword here, add. Okay, so we're only going to be dealing with one operation, which is addition. So here I have 0 plus 4 equals 4. Okay, well that makes sense. 165 plus 0 equals 165. Are you noticing any trend? If you picked up on the 0 in both problems, you're on the right track. N plus 0 equals n. There's that 0 again. So what does additive identity mean? Well, the sum of any number, and remember that could be in a number or a variable, and 0 is itself. So anything plus 0 is itself. That's the additive identity. So you could have 1,752,000 plus 0, and it would equal 1,752,000. Okay, so along the same lines, we're going to have the multiplicative identity. Now again, look at the word. Multiplicative, we're looking at only multiplication. Okay, so think about it this way. If the additive identity gave you a number plus 0 equals itself, then how would you get the same number as the answer in multiplicative identity? Well, let's take a look. 5 times 1 is 5. 3 times 1 is 3. Oh, are you noticing a trend? Look at those ones. M times 1 is M. So, what's the definition? The product of any number and 1 is itself. So, anything times 1 is simply going to be itself. Again, it works for any number, no matter how small or how large it is. Okay. So, we're going to play a little game. You have this in your notes. And I have it here. Now, I am going to be able to move a little bit faster than you with this game because I don't have to write out all of these different things, but you are going to have to. I should be able to, just move them around. So you're going to have to pause the video, and don't be afraid to do that, okay? So all we're going to do is we're going to take each one of these different examples and place them in the correct property category. So is it, and I'm going to even write us a note here, is it associative? That's going to be with our, with our grouping parentheses. Okay, is it going to be commutative, which means it could be in any order? Is it going to be distributive, which means I have a number and then I have parentheses? Is it going to be additive, meaning I'm going to have a plus 0? Or is it going to be multiplicative identity, which means somewhere I'm going to have a times 1? Okay, so let's go ahead and get started. And remember, you are going to have to pause your video to write these down. Okay, so the first one, let's try that again. The first one that I have here is open parentheses, a plus 3, close parentheses, plus b equals a plus open parentheses, 3 plus b, close parentheses. So what I notice is that they're in the same order, but the parentheses are different. They're grouped differently. So that's going to go under associative. Okay, now I have my next one here. 61 plus 0 equals 61. Oh, I see that plus 0 belongs in the additive identity. Over here, I have 0 plus negative 15 equals negative 15. Now, I know we haven't done negatives yet, and that's okay, because the big thing is the plus 0, which means it's also additive identity. So over here, I have the 37 equals 0 plus 37. Again, look at that plus 0. I know I have an additive identity. All right, so over here, I have M times A times P equals P times M times A. So yes, I have parentheses, but that's just to show me they're being multiplied times each other. But what I notice is that they're in a different order. MAP equals PMA. So different order would be commutative. All right, so over here I have negative 98 times 1 equals negative 98. Again, you don't even have to worry about those negative numbers even though we haven't done them, because the big thing here is that times 1, which is going to tell us multiplicative identity. All right, so here we have 4 times h times 6 equals 6 times 4 times h. What do you notice? Well, they're in a different order on each side. So that is going to be commutative. All right. Our next one, we have 6 open parentheses j times 9 equals 6j plus 54. Well, it looks like I have a number outside parentheses and it was passed out to everybody inside. So that is going to be distributive. Okay. Here I have open parentheses h times 2, close parentheses times 6 equals h times open parentheses 2 times 6, close parentheses. What I notice is that h26, h26, they're in the same order. The parentheses are just different. So they're grouped differently, and that's going to be associative. All right, here I have 9, open parentheses, 8 plus 5 equals 9a plus 45. I have a number attached to parentheses, and it's being passed out to the a and to the 5. So that's going to be distributive. All right, over here I have 3 times n equals n times 3. Okay, well those are just flipped, so that means the order is different, so it must be commutative. Over here I have r plus g equals g plus r. Again, the order has flipped and it's addition, so it must be commutative. This guy is a little bit hard, but I bet you can figure him out. So 5 over 5 times 21 equals 21. I'll give you a hint. What is 5 over 5 simplified? Think about it. If you thought 1, you are right. 1 times 21 is 21. That's going to be multiplicative. All right, 2d plus g equals g plus 2d. Okay, well the order is just flipped, so that's going to be commutative. Over here I have 25 equals 1 times 25. Okay, there's that times 1. That tells me multiplicative. All right, here we have open parentheses h plus 8, close parentheses times 3 because it's attached, equals 3h plus 24. It looks like that 3 has been distributed or passed out to the other letters and numbers. So here we have 8 plus open parentheses b plus 5 close parentheses equals open parentheses 8 plus b close parentheses plus 5. Say that 5 times fast. Okay. Now what's interesting here is that it's 8b5, 8b5. So they're in the same order, they're just being grouped differently with parentheses. So that's going to be associative. Here we have a plus 3 equals 3 plus a. That should be pretty easy to recognize. They're just flipped. A3, 3a. That's going to be the ordering property, which is commutative. All right. Over here, I have 6 times open parentheses g times 8 close parentheses equals open parentheses 6 times g close parentheses times 8. Okay, look at it closely. 6g8 equals 6g8. Same order, different grouping with parentheses. So that's going to be associative. And last but not least, 7p minus 35 equals 7 open parentheses p minus 35. It looks like that 7 has been passed out or distributed. So that's going to be distributive property. All right, that is the end of this lesson. Remember, you can always go back, rewind, fast forward, or pause, especially with that grouping activity. You need to make sure that you get all of them down on your paper. And as always, you can ask me any questions in class.